I'm going to solve some of the questions related to condensed matter physics or solid state physics. So the first question, before going to start, if you are new to my channel, please subscribe my channel. Okay, packing efficiency in a crystal is maximum for. So here BCC, FCC, BCT or SCC, because FCC correct option. Maximum number of atoms were present in face centered cubic crystal. So that's why packing efficiency is maximum. When the molten zinc is cooled to a solid state, it crystallizes in SCP structure. The number of nearest neighbors of zinc atom will be. So SCP structure, if we take, then the zinc maximum number of atoms will be 12. A substance AXBY crystallizes in FCC lattice form in which A atoms occupy each corner of the cube and B atom occupy the center of each face of the cube. Identify the correct composition of the substance. So if it is in FCC, then 4 atoms will be there. So according to that, option C. A atom occupies each corner and B atom at the faces of the cube. The structure factor of the single cell of identical atoms of form factor is given by SHKL Miller indices. HKL e to the power minus 2 pi I H x I k y I L z I, where x, y, z, j are the coordinates of an atom, and HKL Miller indices. Which of the following statement is correct for the diffraction peaks of BCC and FCC? So the diffraction peaks, if we take for body centered cubic and face centered cubic structure, then it will be option B. The total specific heat of a metal at low temperature is plotted as a function of temperature, which is shown in figure below. The electronic specific heat can be obtained from the slope of the graph, the y-intercept, specific heat by temperature at dy temperature, or x-intercept. So from this graph, we can have the electronic specific heat that is from y-intercept. This graph is versus Cv by T, that is T square temperature square. So the electrical resistivity of a metal at the given temperature 4.9 into 10 to the power minus 8 ohm meter. If the Lorentz number is 2.45 into 10 to the power minus 8 watt ohm per Kelvin square, the thermal conductivity of the metal will be. As we know, resistivity and conductivity are inversely proportional. Then if rho is having the smallest value, then conductivity must be high. 59, option A, 150 meter per Kelvin. It is difficult to determine the Hall coefficient for a metal as compared to a semiconductor because the Hall coefficient will be too small, Hall voltage will be very high, Hall effect will not be exhibited in metal, Lorentz force will not act on free electrons. So the option here 60, option A, Hall coefficient will be too small. At low temperature, the Seebeck effect is mainly due to phonons electrons change in Fermi level phonon drag of the electron. Option D, because of phonon drag of the electron. Here phonon are the field particles of crystalline materials. In solid state physics, we call the field particles as phonon. Due to the breaking of periodicity at the surface of a semiconductor, impurity states are created in the band gap. Doping of the semiconductor takes place. Surface states are created in band gap. Extended states are created in the band gap. Option C, surface states are created in the band gap. In an indirect band gap semiconductor, for an electron to get excited to the conduction band only when photon energy higher than the band gap is required. Phonon is required. A photon of energy higher than the band gap and a phonon are required. Photon and temperature are required. Option C, that is photon of energy higher than the band gap and a phonon are required. Josephson effect provides a standard for temperature, voltage, resistance, energy, voltage.